Find the x-coordinate of all points on the curve y equals the sine 2x plus 2 times the sine of x at which the tangent line is horizontal, and then consider the domain where x is equal to 0 to 2 pi. So let's write this function out. So we know the function is y, which is equal to the sine 2x plus 2 times the sine of x. Okay, so if we want to find the derivative of this function, okay, we're going to have to use the chain rule for the first term here. So we want to find what is the derivative of the sine. We know the derivative of sine is the cosine, and that's going to be the cosine of 2x. And now we need to take the derivative of the inner function, and the inner function is 2x. So I want to find the derivative of that. And then plus 2, derivative of 2 sine of x is going to be 2 times the cosine of x. Okay, now when we take the derivative of 2x here, we have the cosine of 2x times the derivative of 2x, which is 2, plus 2 times the cosine of x. So ultimately this 2 is going to be 2 times the cosine of 2x plus 2 times the cosine of x. So therefore that's going to represent the derivative of the function. So now what we want to do is we want to rewrite this so that we can determine what are all the x-coordinates at which the tangent line is horizontal. So we need to rewrite this cosine of 2x in another form. And so by doing that, we're going to say, okay, well, we're going to rewrite this function so that it is 2, and then we're going to replace the cosine of 2x with an identity. So if you notice here, here's an identity. We have the cosine of 2x, which is cosine squared x minus sine squared x. We have 1 minus the 2 sine squared sine x, or we have cosine 2x is 2 cosine squared x minus 1, and then the following. What we want to do is we're going to use number 3. Okay, so we're going to replace this to be 2 times the cosine squared x minus 1. And the reason why we're going to do that is we're going to be able to rewrite this into a factoring form so we can figure out what those values are. So the next thing we're going to do is we're going to distribute this 2. So we end up getting 4 times the cosine squared x minus 2 plus 2 times the cosine of x. And now we're going to rewrite this as 4 times the cosine squared x plus 2 times the cosine of x minus 2. Okay, so what we want to do now is we want to set this equal to 0. So in step number 3, we want to set this 4 times the cosine squared of x plus 2 times the cosine of x minus 2, and then we're going to set that equal to 0. And so what we want to do is we want to be able to factor this. So let's go ahead and do that. So we're going to go ahead and factor. So the first thing we can do is we can factor out a 2. So if we factor out a 2, we have 2 times the cosine squared x plus cosine x minus 1, and that's equal to 0. If we divide both sides by 2, then we end up having 2 times the cosine squared plus cosine x minus 1, and that's equal to 0. So we need to factor this by using the AC method. Okay, so by using the AC method, we know the value of A and C is equal to 2 times negative 1, which gives us negative 2. And then we know that when we have AC and then the value of B So we know that this is -2 and the value of b is 1. So what two numbers can we multiply to get -2? Then when we add them together, we're going to get +1. We can get -1 and then +2. And so therefore, we're going to end up with the following. We're going to have 2, let me put this x here, times the cosine squared x, and that's going to give us minus the cosine x plus 2 cosine of x, and then minus 1. So now we can factor by grouping. So if we factor by grouping, we can factor out a cosine x in the first one, so we get 2 times the cosine of x minus 1. And then we should get the same thing over here, 2 times the cosine x minus 1, so we can factor out a 1. So now in step 4, we have 2 times the cosine of x minus 1 times the cosine of x plus 1. Now we're going to rewrite that up here in step 3. So now we know that we factor this to get 2 times the cosine of x minus 1 times the cosine of x plus 1. And then we're going to set that equal to 0. So the first thing is we have 2 times the cosine of x minus 1 equals 0, or the cosine of x plus 1 is equal to 0. So when we solve over here, we're going to get 2 times the cosine of x, which is equal to 1. So then we have the cosine of x, which is equal to 1/2. Or over here, we're going to get the cosine of x, which is equal to -1. Now again, we want to be able to find the x-coordinate of all points on the curve at which the tangent line is horizontal. And then we're going to consider the domain of x, which is equal to 0 to 2 pi. So what we want to do is we want to find out, okay, what is the angle for when the x-coordinate is 1/2? So if we take a look at our unit circle, okay, down here we want to find out, okay, where is the x-coordinate have, so you can see here, here's an x-coordinate of 1/2, and that's pi over 3. Okay, is there another x-coordinate? There's another one that has an x-coordinate of +1/2, and that's here. Now recall here that the domain goes from 0 to 2 pi. So that means it goes in 1 revolution. So we know it goes over in 1 revolution. Since it goes in 1 revolution, we know that we have x, which is equal to pi over 3. We know it's 5 pi over 3. Okay, and then we got to figure out what is the angle for when the x-coordinate is -1. So let's take a look at that. So where do we have an x-coordinate of -1? We can see it's here, so it has an angle of pi. So therefore, our answers are pi over 3, 5 pi over 3, and then pi. And then if we want to put it in the correct order, then it would be x, which is equal to pi over 3, pi, and then 5 pi over 3.